Good morning, students. Today in this video, we're going to study about work done in adiabatic process. In the last video, we have already studied in work done in adiabatic process, work done in isothermal process, work done in isochoric process. So maximum work has been done under isobaric process, and minimum work, which is zero, under isochoric process. And work done in isothermal process also already we have studied in the last video. So in this video, the last one, which is your work done in adiabatic process, we are going to study. So let me share the screen. So this gray color is the PV diagram for adiabatic process, and area under this process, which is your this gray area, I have already marked it. This is your work done in adiabatic process, and this is the PV diagram for different thermodynamic process. The red color is PV diagram for isobaric process. There is green color is PV diagram for isochoric process. Pink color is PV diagram from isothermal process. This gray color is PV diagram for adiabatic process. So as we can clear from the graph or from the PV diagram that maximum work is done under isobaric process and minimum work is done in case of isochoric process, which is your minimum area or zero area under this green line and maximum area under the red line. And if we compare, which one will be more? This is your isothermal process. Pink color is isothermal process, and this gray color is adiabatic process. So comparing adiabatic and isothermal process, we can be clear maximum work is done in case of adiabatic process. So let us come to that point, work done in adiabatic process. So work done in adiabatic process. What is an adiabatic process first? So adiabatic, in case of adiabatic process, no heat enters or leaves the system. Heat cannot be allowed to go in or heat cannot be allowed to go out of the system, as the system enclosed by adiabatic wall. That means gas or walls of the cylinder are perfectly non-conducting and the piston is also non-conducting. Here pressure, volume and temperature change from Pi, Vi, Ti to Pf, Bf, Tf respectively. So the work done, we know the thermodynamical work done is given by W equal to integration of PdV from lower limit Vi, upper limit Vf. Since the equation for adiabatic process, we know PV to the power gamma equal to constant, where gamma is Cp by Cv. Gamma is a constant known as Cp by Cv. So P equal to K, P become K divided by V to the power gamma, or P equal to K V to the power minus gamma. So substituting this value in equation 1, we can get W equal to integration of K V to the power minus gamma into dV. So that equal to W equal to K is constant, so it will go outside of the integration. K integration of V to the power minus gamma dV. And from the equation, we know x to the power n dx integration is nothing but x to the power n plus 1 by n plus 1. This is the basic formula of the integration. So V to the power minus gamma, we can write V to the power minus gamma plus 1 divided by minus gamma plus 1, lower limit Vi, upper limit Vf. So putting the values of upper limit minus lower limit, so minus gamma plus 1, it will go outside. So W equal to K by 1 minus gamma, bracket V to the power Vf to the power 1 minus gamma minus Vi to the power 1 minus gamma, upper limit minus lower limit. Then W equal to 1 by 1 minus gamma. In place of Vf, we can write multiply K. So K you take into the bracket. So K Vf 1 minus gamma minus K Vi 1 minus gamma. So W equal to, W can be 1 by 1 minus gamma, bracket, in place of K, I have written here Pf Vf to the power gamma. As we know, equation for adiabatic process is PV to the gamma equal to constant, or PI VI to the gamma equal to PF to the VF to the gamma equal to K. So in place of K, in first K we will put PF VF to the gamma, and second K we will put PI VI to the gamma. So on solving, VF to the gamma and VI to the 1 minus gamma, so it become PF VF and this become PI VI. So W equal to 1 by 1 minus gamma into PF VF minus PI VI, or we can write W equal to 1 by 1 minus gamma. In place of PF VF we will write NRTF, and in place of PI VI we can write NRTI, because PV equal to NRT we know. So PI VI equal to NRTI, PF VF equal to NRTF. So NR if you will take outside, W equal to NR by 1 minus gamma, TF minus TI, or TF is final temperature, TI is initial temperature. So if I make, as we know, gamma is always greater than 1. So gamma minus 1 if I will write, so this inside become TI minus TF. So W equal to NR by gamma minus 1 into TI minus TF. So in case of an adiabatic expansion, that means if the gases expand, work is done by the system, and here W is greater than 0. We know W is positive. In case of thermodynamical work done by the gas or by the system, W is positive. So if W is positive, that means this right hand side also will become positive. So when the right hand side will become positive, so this NR by gamma minus 1 is positive, TI minus TF will be positive. So TI minus TF will be greater than, so positive. So TI minus TF is greater than 0. That means TI greater than TF, or we will write TF is less than TI. So that means temperature of the system decreases. So in case of expansion, temperature decreases. In case of adiabatic compression, work is done on the system. On the system means work is negative. W is negative, or W is less than 0. So if W is less than 0, that means this right hand side also less than 0. So this is less than 0 means TI minus TF is less than 0. So TI minus TF less than 0 means TF is greater than TI. That means final temperature will be more than initial temperature. So the temperature of the system increases in case of adiabatic compression. That means if আমি যেতবেলে সাইকেলে হাওয়া মারছু হাওয়া দেছু, so that is what adiabatic expansion. So temperature adiabatic compression, so that is temperature increases, and যেতবেলে আমি হাওয়া খুলে দেছু টিউব রু, so adiabatic expansion. So in case of adiabatic expansion, work is done on the system and final temperature will be less than initial temperature. So সেটা কারণে আছে हमको সাইকেল টিউব খুললে ঠান্ডা লাগছে and সাইকেলে হাওয়া হলে গরম লাগছে. Thank you.